Ready? Yeah. Okay. Let's talk about some application security. This is one of my favorite talks, so I hope you enjoy it too. Start with a little bit of background. Who am I? I'm a developer. Please don't hurt me. I know I'm probably in a room full of admins. With that, security's been an area of interest of mine for many, many years. I like to think that I am one of the developers who's very much aware of the things that I don't know, because that's one of the essentials of writing secure code, is being aware of all the things out there that you may not know. As Donald Rumsfeld stated so well, there are things that we know, there are things that we don't know, and there are things that we don't know we don't know. And that is usually where you fall down in application security. So I won't say I'm perfect. I'm working at being better constantly. So I've been doing this application development stuff for many, many years. Getting out there and doing security talks is one of my ways of giving back to the community, making sure that other developers don't make mistakes that cause your servers to get compromised. So what are we going to do? We're going to do application security. And like I said, you don't know what you don't know. One of the best metaphors I could come up with for this was a game of Clue. You start the game, you don't know anything, something bad has happened, you need to find out what happened. What we're going to do is we're going to work our way through some of the characters include that really helped me to get some mnemonics down for the top 10 application security vulnerabilities that are in the wild today. This talk is heavily based on the OWASP top 10. OWASP, O-W-A-S-P, the Open Web Application Security Project. These threats are extremely prevalent in many, many web applications out there. The examples I'm going to give tonight are in .NET, but this is applicable to PHP, even more so than .NET. Java server pages, Ruby on Rails, Python, you name it. If you're rendering something back to a user, your application can be vulnerable. Some of these threats are also relevant to mobile applications, especially to desktop applications, to anywhere where someone has control and can send you data that you may accidentally end up trusting. So we're going to play our little game called How Did Mr. Body Get Hacked? And why do we care about application security? We care about application security because of these two charts. These are some of the top application weaknesses studied live in the field from feedback, along with the top methods for attacking applications. So if we look, we can see that SQL injection is still a fairly significant attack vector, and with that, that means that someone's getting into your back-end SQL servers and running code and queries and all sorts of fun stuff. Denial of service is still big. Cross-site scripting, XSS attacks, not properly sanitizing your inputs and outputs is also a significant attack vector. And again, we can see in our weaknesses in our applications, improper input handling counts for 19% of vulnerabilities in applications. That means your developers aren't doing something right. They're trusting when they shouldn't be. Improper output handling, 15.2%. That's your cross-site scripting vector right there. So application security is a real concern, especially because over the past years, operating systems have become hardened. Server pieces have become hardened, IIS, Apache, all of those are becoming hardened. So where are the majority of the vulnerabilities happening? They're at level 7. They're in the application code, something that a lot of administrators don't necessarily have control over. And like I said, I'm doing my best to talk to developers about this, but it's good for admins to understand the developer perspective as well, and also to pick up on, if you guys understand lower level vulnerabilities, but there are things that you can be aware of at the higher level, at the application level, to look for that can give you a heads up on this. There are products out there that try and do application level firewalls and filtering. I've never personally experienced the use of any of those to great success. I don't know some of the better ones. It's certainly possible, but it's not going to be a good substitute for knowing how to code securely and taking this information back and building it into your own applications. So we'll start with our first attack. Was it Miss Scarlet in our database with a SQL injection attack? Now, SQL injection attack is lack of input filtering. You're taking what the users are giving you and you're trusting it. What I'm using for my demonstration code is this little application called webgoat.net. It is publicly available. It's open source from OWASP. This is a purposefully broken application. It purposefully has security vulnerabilities in it so that we can walk through them, demonstrate them, and also talk about the countermeasures to these vulnerabilities. So we'll start with our first vector here, which is SQL injection. And what we've got is this little email address finder. We want to sign up for this mailing list. Everyone's got this. We all have this sort of marketing stuff out there. And we're going to go ahead and we'll put in our email address. We'll say, am I on there? I'm not there. OK. So let's go ahead and exploit how we can join our mailing list. I'm not on the mailing list, but I want to join it. So I'm going to say, put in my information, add me to the list. Well, if I'm an attacker, I just found something pretty interesting. Some developer left logging or something turned on to make their life easier. I get a little hint about the database structure. That, okay, there's some SQL that it's telling me it's logged back to the screen, but that may or may not be there. But if I try and add myself to the list again, I see, okay, I'm already on the list, and it now says, oh, and by the way, you're on the list, and we'll tell you, we'll give you back your information so you can see it. Perfect. I'm an attacker. I now have a data exfiltration path. I can get information out of this database too, in addition to potentially doing other things with SQL injection to make it, to alter the data, to do other things. So now I've got a way of data exfiltration as well. And just so you don't have to sit and watch me type, I have some previously written little injection code. So coming in here, instead of an email address, I'm going to say as an attacker, I suspect that this developer is not doing proper input filtering. So I'm going to try and do a real quick injection attack. And knowing that this is an ASP.NET site, I also strongly suspect that there's a SQL Server backend to this. However, finding out which database backend is a fairly trivial exercise. I'll be honest, what's actually in the back end of this is a SQLite database, but it's very much like SQL Server. So I'm going to start with my email address, and I suspect that this developer is just doing string concatenation for building these queries. So I'm going to take advantage of that by putting in a terminator of the string of a 1, and then or 1 equals 1. That's always going to be true. And then a couple of dashes, which is the SQL Server comment character. So it's going to comment out anything that's going to be concatenated into that query string after it. And if we pass that into the web form, what do we get? Well, we get that we're already on the list. And then we also get the full list of anyone else who's signed up for this mailing list. Great. Your competitors will love it because I can sell it to them. I can do more than that. Like I said, we have this data exfiltration path, meaning that we're getting a first name, a last name, and an email address of everyone in this table. That's nice. I want to know what else is in this database. Since we're doing query construction through string concatenation, more than likely the account that's accessing the database has at least read access to every single table in the database. I want to go and I'm going to find out what other tables are in this database that might be interesting. There might be accounting data in there. There might be customer lists. So we're going to go ahead and do our usual, terminate that string concatenation and then an or 1 equals 1. And then we're going to union. We're going to make another query and return its data back as well. And to do that, we're going to go off to the metadata tables, and we're going to get the names of all the other tables in this database. And again, that's coming from SQLite master. If this was SQL Server, it'd be from sys.tables. And then importantly, end with 2 dashes, our comment character, so that now when we pass this data back in, we have not only all of the users, which there are many of them, we also have the list of all the tables that are in this database. And we can see there's postings and a user list. So nothing real exciting in this one, but if it were your production database, what else is in there? What else could I get out of it? Not only that, but I'm sitting in the coffee shop. You don't know me. I'm going to test your backups from here. I'm going to make sure you've got good backups. I'm going to do that by passing in one more query. And I'm going to use a query terminator, the semicolon. So I've got one query of, or 1 equals 1, so it's going to evaluate the true semicolon. And then we're going to go ahead and delete everything from mailing list. And then comment out the last, so our concatenation works. And what happens when we run this? We'll go ahead and add ourselves to the list. And now, if we take our original injection script and just list everyone in the mailing list table, there's nobody there. All right. Now we'll see how well you can restore in a timely manner. Of course, I did that after I swiped all the customers out of your customer table. There's more than just SQL injection. The main vulnerability that we were exploiting here was the fact that we were trusting user input. We trusted that someone was only going to come in through this form. We may have trusted that there was some JavaScript validation that was going to happen. We're trusting that the user is only sending us what we expect. Developers are optimists. Ops people are pessimists. And in the world of security, optimists get hosed. User input is evil. That is the overriding motto of a good application developer. Because what we're doing is we're taking advantage. And like I said, even if there was input validation, JavaScript or whatever, I don't need to go through your web form. I'm an attacker. I can use curl. I can use whatever else I want because I'm just posting HTTP, I'm posting to your HTTP endpoint, and if your developer is just accepting it, then they're going to take it. Yes?
So it's not just, I can't use this, it's not just what they put into the fields, it's anything that's provided by the client, CGI environment variables, stuff like that.
Absolutely, yeah. It's not just what you put into a field. There are, if you're doing some sort of querying with XPath, and you're not properly sanitizing that input, I can do an XPath injection attack and walk your XML documents and get information back out. Another fun injection attack is we've got some documents here that we provide as a download to our users that they can go off and get these documents that we host and read all about how great our company is. Now, I'm going to copy this shortcut and paste it into a text editor so it looks a little more easy to see. I need a better. We'll make it a little bigger here. So what do we see? We see that we've got a URL, and in it we're passing in a file name. Awesome. Let's take that, and instead of doing architecture.pdf, let's see if this developer is on the ball. And we'll see if we can get their web config file off the server. Now, web config is a protected file. IIS is configured to not ever serve that file to the end user. I don't care. I'm not accessing it as an end user. If this works right, I'm accessing it as through the application process on the server. So if I have that typed in right, and I paste it into my URL, I get, oh, do I want to open or save web config from contoso.com? Let's go ahead and open it. And now it's going to wait while it fires up a whole new instance of Visual Studio for us to see this web config. Let's see. Let's just open the folder instead. Should go there. We go on my temporary files. Edit it with Notepad. And there's our web config. What's in here? All sorts of fun stuff. Connection strings, possibly with SQL usernames and passwords. Credentials of administrative users, anything that we might want to, encryption keys. God knows what could be in here that we don't expect end users to see, but because the developer because the developer trusted that end user input, we just served it up to them. We can also grab the application code files off the server if they're on there. Navigate up a couple directories, go off and grab the password database from off the server so we can start running the password hashes through LoftCrack and cracking whatever passwords are local on that box, which may then lead us to some domain accounts that have the same password or similar passwords, things like that. So SQL injection, again, it doesn't matter how many firewalls you have, whatever else is in the way. I'm not attacking your firewalls. I'm not attacking your application. I'm going through your application server all the way back to your database server, getting away with running whatever commands I can in that database that the application login has permissions for. If you're running as sysadmin, if the login is running as sysadmin, I can turn on XP command shell on the database server, start running applications, run a remote shell on your database server with whatever credentials your database process is using, which could very well be local system because someone told you to set it up like that because they needed those permissions. So now I'm back on your database server, passed straight through your firewalls, nothing, passed right through your application because I just took advantage of your trusting nature. Thank you very much. How do you mitigate this? Don't ever trust user input. Constrain, constrain, constrain. What works best is if you must accept input from the outside world, whitelist it. Make sure that you've got a very small amount of things that you're accepting. And with SQL, with XPath, with a few other things, make sure that you separate your data channel from your command channel using parameterized queries. Never, ever, if you ever see string concatenation anywhere in a SQL statement, that is a horrible flag. Teach your developers about parameterized queries. They're supported in every major development language. Every major data access technology supports these. If your developers are using the majority of the object relational mappers that are out there, most of the time they'll be protected because most of the major ORMs do this automatically. They do parameterized SQL. However, they all offer the developer a way to drop down and pass SQL straight through. That is a major area of risk because you can really only catch it in a code review. Some people say stored procedures will protect you. Not necessarily. They do give you some command and data separation until you get into the body of the stored procedure, where your developer, especially if they're writing some sort of search procedure, is probably doing string concatenation inside the stored procedure, so then you've got that SQL injection vulnerability right there. So the main defense is always separate your command from your data and always make sure that things are code reviewed and always watch for those concatenation areas. That will bite you. All right. Wasn't that fun? Anyone need to head back to the office yet? All right. Well, next was it Mr. Green in our forums with cross-site scripting. Cross-site scripting is another fun one that, again, doesn't matter how many firewalls you have or whatever else. I can't necessarily get to your back-end server, but what I can do is make your user see whatever content I want them to see from my server. So I'm going to bounce through your app server. It's going to look like it's coming from you, even though I have complete control of the content. And what am I doing? I don't know, maybe I'm rendering a login form that looks exactly like yours, except the destination for the username password is my server, not yours. And then I tell the user, oh, sorry, re-enter your password, and I'll let them just pass right through. But now I've got their credentials, or I'm piggybacking on their session, or I'm stealing their cookies because your developers didn't set the cookie parameters right, so I can grab their cookies from JavaScript and start using them. So how does cross-site scripting work? Luckily, I have a demo for that too. There are two major types of cross-site scripting. Stored cross-site scripting and reflected cross-site scripting. They both work in very similar ways, except one takes advantage of the fact if you're accepting user content and reflecting it back out without properly output encoding it, I can take advantage and actually start to affect a lot of people at once, whereas reflected cross-site scripting is more of an individualized attack, or something that I send people links to. So we'll start with stored cross-site scripting. We'll see we've got our classifieds here. We've got this classifieds, and we've got a way of being able to make our own classified listings. So we'll make one that says, hello. So we just make a nice simple post. Then we hit save, and there it is. This is a new post. I don't see the harm in that. Okay? What if, instead of normal content, we pass in a little script tag? What do we think is going to happen? Well, it's going to get sent to the database, probably stored, and rendered back out to the user. How's it going to work? Let's go ahead and add that listing. Bing. Now, whenever anyone else hits that page, our script is going to execute. Every time. So that's not too malicious. That's kind of annoying. But what if we did something else? What if, and again, in order to save you from having to watch me type this, we take this little script And what's this script going to do? Well, this is going to go off to evilcode.com, and it's going to load up this JavaScript file called evil.js. And there's our hello. And there's some evil content right in the middle of our form. How does that work? Well, it looks like it's your content. The address bar says it's yours. I trust it. It looks like you. It's got your SSL cert and everything else. What do we have here? We've got a little bit of JavaScript. And all we're doing is creating a little iframe. And in this case, I just have it 200 by 200 pixels, and we're rendering our EvilCo index page in there. But like I said, if I wanted to, I'm going to take it and I'm going to make it 100% iframe. I'm going to duplicate your login form. I'm going to start grabbing credentials. I'm going to start annoying people. I'm going to start putting up bad content, whatever else, that you guys are under investigation by the IRS now for tax fraud, whatever I feel like doing. And it all looks like it's coming from you. Now, there's also reflected cross-site scripting. So in this, we've got a couple of links here. And we see that there's a little parameter on there that says what classified ID to use to show on this form. So if we put in something that's not actually a number, we see, oh, it says record foo not found. Great. I have a new vector. I can now actually pass script. Oh, darn it, IE caught me. All right. I'm not going to fire up Chrome or anything else. IE actually caught me on this one. I wasn't expecting that. It didn't do that in my demo earlier. But let's see if I can turn that off. No. All right. Browsers are getting better. But I will say, when I did that stored cross-site scripting, I did cheat just a little bit. And we'll talk about that now, because now is the time to talk about mitigations. Cross-site scripting occurred because we were not correctly encoding our output. We as developers got this input, and we didn't think that, oh, someone could give us something that we're not expecting. Someone could give us a chunk of JavaScript or something else, and we'll just render that. Well, what happens when you render JavaScript? The browser says, hey, that's JavaScript. I know what to do with that. I'm going to run it. And that's exactly what happens. Solution for evading stored cross-site scripting especially is whenever you're rendering untrusted content, anything that you got from anywhere else, anything that you're not explicitly creating, is you HTML encode it. It's simple. It's a function that's in every programming language, can do this. And what it does is it would actually render the HTML tags for greater than, for less than, for the semicolon and quotes and all that, instead of the actual text. We'd get a ampersand LT script, ampersand GT, and that would just show up as content in our form. It would not be executable because the browser wouldn't see it as JavaScript or a script because it didn't look like it because it was correctly encoded. Like I said, I had to cheat just a little bit to get that to work easily, where I could put that script tag in. And if we actually look at our web config, which I still have here open from when we opened it before, we can see where is it at? In our, there it is, in our pages, we've got this validate request set to false. I had to explicitly turn off built-in defenses against cross-site scripting. ASP.NET comes with built-in defenses for cross-site scripting. If you see this list here, this is a couple of hundred different ways that people have found for encoding content that can result in cross-site scripting. ASP.NET comes with what's called the Microsoft Web Protection Library built into it, and that has defenses, it has detection routines for many of these cross-site scripting encodings so that I could not go into a form and submit something very simple with that script tag. I'd have to really search for something that wasn't in that library for encoding that content to get the browser to run it. Every time you go to a new version of ASP.NET, you get a new version of this library because it's constantly evolving. More than that, what I would recommend for your developers is to go out and get from NuGet.org. NuGet is a package management system. Makes it really easy to bring in third-party dependencies into your applications. And the ASP.NET team has open sourced this library. They have it out on CodePlex. You can download a new version of it and plug it right into your application. Better than that, your developers can use NuGet and always make sure they've got the latest version on every build. What does that give you? Well, ASP.NET revs every couple of years, so you could be 2 to 4 to 6 years behind. Leave yourself open to some of these other cross-site scripting vulnerabilities that you could be automatically protected from if your developers would just go out and take advantage of this free, open source, supported by Microsoft, easily updatable library for evading cross-site, for catching cross-site scripting vulnerabilities and stopping them from happening. Some other languages have similar functionality. I know Ruby on Rails tries to do a lot of anti-cross-site scripting detection. PHP, not so much. You're kind of dependent on what you write. And again, this is where HTML and code is your friend. Any user input that you're going to reflect back, make sure that you HTML encode it. This also means this is a vulnerability if you're doing something like I said, taking a parameter off of the URL and using that in your JavaScript on the page that's rendered. I can inject additional JavaScript into there that will get built in line and executed. I can do that similar to like how we did SQL injection. I can do JavaScript injection through some of these cross-site scripting vulnerabilities. If you're taking some content from the page that I can have control over, or taking some input from a parameter from a post value and using that in the JavaScript that you're then rendering to the user, I can inject my JavaScript into that as well, which is, again, something that HTML encoding will mitigate. Okay. Questions so far? All right. For our next suspect, was it Professor Plum in our session management with incorrect session state management? What you'll see right there is what is very similar to what's in our address bar right now, where I have this big blob of cruft in my URL. Why is that there? I'm running in a web farm environment or something like that, and I've turned cookieless session state management on. We all know HTTP has no concept of state, and every request is new, so there's got to be some way of tracking for people's sanity that, hey, I've seen you before, I know who you are, here's what you were working on before. We manage that with session state. A couple of different ways to do it in the world today. One is put a bunch of crap in the URL that the ASP.NET framework knows how to handle and maintain session state for us there. Vulnerability for that is I'm sitting in a coffee shop watching all the web traffic go by because I got myself a pineapple or something like that. I'm watching what's going through in the URLs. I grab that, use that in my browser, and I'm you to the server. I can very easily impersonate you that way. We can mitigate that by actually turning it off. Again, that was not the default for ASP.NET. But now we've got a nice clean URL because I turned that off. I still have session though. If I do something like log in, if I can remember that password. There we go. So I'm logged in. It knows who I am when I go from page to page because our session state's maintained by a cookie now. And I'm using the built-in ASP.NET authentication and authorization provider, so it's fairly secure. I know, because it's ASP.NET, that the cookie is not accessible from JavaScript. It's flagged to be HTTP only. So I can't craft a cross-site scripting attack and grab that authentication cookie. If your developers aren't careful, if they roll their own frameworks, if they're using PHP or something else in their own version of a session state provider, they could have accidentally exposed those cookies to being grabbed through JavaScript. Later on, we're going to talk about why you should always use SSL everywhere. This is also something you need to be aware of with cookies, is especially for authentication cookies and authorization cookies, something that's maintaining that user state of, hey, this is your unique identifier for this session. Those should be SSL only. You never want to pass those over an unencrypted connection. Why? Because I'm an attacker sitting in a coffee shop route looking at your traffic. I see those cookies go by because they're in the header. They're not protected by, if they're not protected under SSL, I grab them and I'm you. A couple of years ago, this was a major vulnerability in Facebook. There was a Firefox add-in called Firesheep that was released, and you could sit there and have this running and watch, sitting in a coffee shop, seeing everyone on Facebook, watch what's going on in their sessions, click on their picture, and become them. You get their homepage, you can start posting comments as them, read their messages and whatever else. Why did that happen? Because those cookies weren't being passed over SSL, they were over HTTP. So they were really easy to grab and reuse. Okay. So like I said, our mitigations are always make sure your cookies are HTTP only, and especially with authentication ones, make sure that they're over SSL only. So was it kernel mustard in our API with a direct object reference? For those of you who don't know, that's a Columbus security guy called Bill Semp. He's also a Locksport. He's really hilarious, and I love giving him a hard time in these presentations. He's there because he gets the honor of documenting this particular direct object reference. A direct object reference is an attack that can potentially leak personally identifiable or private information. It can also expose and allow unauthorized access to applications. So how does it work? We're developers. Not only are we optimists, we're lazy as well. We've got the SQL database, and it's got an identity column in it. Every customer gets a new ID, and it's always 1001, 1002, 1003. Great. We'll use that. We'll put it on the URL. I'm going to look at my account, user ID equals 1001. Okay. Well, I'm a little bit nosy. I want to know what's user ID 1002. I can put that into my URL, and I can maybe see their data. I can maybe do things as them. There have been vulnerabilities in banking systems that allowed access to other people's accounts by virtue of a direct object reference that someone got a hold of, incremented it by 1, and started looking at someone else's account. This particular example is from the Facebook social graph. So by definition, this is information that you've made public. So this is not necessarily a vulnerability, but it is the same class. Bill was looking at it, and he saw he's got this big, long ID. And he sees his information when he puts that into the request. So he says, OK, well, what happens if I look at the next number up? And Facebook comes back with, well, that's Mary Louisa, and here's her information. Again, this particular one is public, but if you can imagine on your systems, it could be private information, it could be someone's account. And also, if your developers aren't doing authorization checks on every page of, hey, does this account actually have access to this data? Or if they're trusting and it comes in and says, I'm account 123, they say, OK, you must be account 123. Here's the information. How do you mitigate this? There's a lot of libraries out there. OWASP has open source libraries for just about every platform out there that gives you a really easy to use way of generating a proxy value. Even better, that value can be set to expire, so you've got this window where it's valid, so you can still give someone this direct link to come in. This isn't a monotonically increasing number that actually means something. It's a GUID, it's some random information, and even better, it may only be good for the next day, the next 2 days, the next hour, what have you, and then it expires. So if someone takes that link and accidentally emails it to their ex-wife, that particular proxy value hopefully will have expired at some point in time, and their ex can't get into their banking account that way. So the major mitigation for this risk is to not ever expose this to an end user, because A, they shouldn't care about it anyhow, and B, it opens you up to some vulnerabilities where if you're not extremely careful 100% of the time, and nobody ever is, you could be exposing personally identifiable information when you don't want to. Or were we hacked by Miss Peacock in our forms with cross-site request forgery attack? This is my absolute favorite attack. Again, firewalls don't matter. What happens is I take advantage of your trusting nature and your users' gullibility, lack of focus, being overworked, doing too much at once. And I take advantage of their credentials to do things in your application. How do I do that? Well, we're all making things easier for our users. We don't make them re-authenticate with every single request. We keep their session. We know who they are. That means if I can trick their browser into doing something, it will do it with their identity and their credentials. as I said, we've got our application, and what we have, what I built, is once I find that URL, where did I put it? Diary. I'm trying to access a diary function. I built a diary function. What that lets me do is make an anonymous posting to our forum. But I am a developer who is somewhat aware of security. So in my code for the diary, I made sure to say, hey, you can only access this if you are logged into the application. And let's also pretend that I put in there that you can only access it if you're logged in as an administrator. That's just one more little attribute that I need to put on. So I am secure. You can't make a diary entry without me knowing who you are and you being logged in. So now if we log in, I really should write this password down. There we go. So we're logged in, and now we have our diary. We can make an anonymous entry. So this is super secret. Now if we go back and we look at our classifieds, we'll see there's our secret entry from an anonymous user. That's super secret. Okay. So how does this attack work? It works by I have a little HTML page that I'm hosting on my server on evilco.com. It's called csrf.html. It's just a simple HTML page. What do I have? I have a form. And what's that form? It's going to post to your endpoint, to what the diary is expecting the post to be sent to. I've got an input that's the same name as the one on your form, a value that I want to put in it, and I'm going to hide it. And then I've got a little JavaScript that's going to go ahead and submit that form. Now, I know Bob in accounting is an administrator on the system. I also happen to know Bob is a big nut for frogs. He loves frogs. He's got them all over his desk. So I'm going to send Bob an email with this link that says, hey, check out this video of these dancing frogs. You'll love it. It's awesome. So Bob is going to fire up his browser, and he's just going to click on that link. And it's, oh, that's weird. I got back to the page. Oh, well, it must have been one of those things, right? Well, if we go and we look in our database, we now have another secret entry that's got the text that we wanted put into that diary. What did we do? We took advantage of Bob's credentials being stored, of him being gullible. I could have taken advantage of that cross-site scripting vulnerability and just put a little script in there that did a redirect instead, so that anytime anyone went to the forum, it would redirect off to my page and then bounce them back to the forum. Or if Bob has access to the payroll system. And I haven't had a raise in the last couple of years because there's a recession, but the CEO just got a bonus, and that's not really fair. So I think Bob needs to give me a raise if there's a cross-site scripting vulnerability in the payroll application and I can find it and I can get him to run it. Who's going to get fired? Bob's going to get fired because the audit logs show it was Bob. Came from his computer, his login, his credentials, and he did it. So it's his fault. This happened because the diary form that was rendered was not, and the code that accepted that form was kind of naive, and it just put out a form and it took whatever from anyone. And as long as someone posted to it with the right field names and with the right authentication headers, it would take it and do whatever it was supposed to do with it. How do we defend against this? Well, if you're using ASP.NET web forms, the original ASP.NET stuff, you are mostly protected by accident. Because every form has view state by default with it, which is this big blob of encrypted encoded text that goes out with every form that tries to keep a track of what's there. That protects you because that same view state blob has to come back with that session, with any submissions on that session, and it has to match, or else ASP.NET says, hey, wait, something bad happened, your view state's corrupt, and it throws your input out. That's all well and good until your developers are all hot and bothered about ASP.NET MVC, and they say, that's the greatest thing, we got to use MVC, it'll make everyone's lives easier. It does, but it also means that you're left a bit defenseless because your developers may not know that they need to use this validate anti-forgery token attribute whenever they accept input. What does that do? What that's going to do is that's going to render a canary value onto the form. It's a little hidden form field with a unique value that's also stored and sent back in a side channel through JavaScript that has to match. So it's a defense against cross-site scripting. It's not perfect, or I'm sorry, it's a defense against cross-site request forgery. It's not perfect, but it's better than nothing. With this attribute, and then in their view, they do a little HTML helper to emit the anti-forgery token. You have to have both parts. The view has to emit the anti-forgery token, and your controller has to validate it. Ruby on Rails has this built in usually as well. You have to explicitly turn it off, I think. Straight up PHP doesn't have it built in, but there are a lot of libraries and frameworks that put it in. Really, there is a library to do this on any platform. It's just a matter of opting in and using it, and it's usually pretty simple. What I have done personally is I've built action filters in ASP.NET MVC to make sure that any controller actually has this anti-forgery token in it, or you can have your developers inherit from a common base controller that has it on it, things like that. I also play with an aspect-oriented programming tool called PostSharp. And I can build compile time validation rules with it. And I have some open source on my Bitbucket account where I can actually, I use PostSharp, I use the free version of it. And when the developer compiles, it'll look at all of their controllers, and anywhere that it's accepting a post, if it doesn't have this validate anti-forgery token on it, it'll give them a compilation error, and they can't even check the code in because it won't compile. And technically that should be there on our post. Okay. For our next attack, is it Mrs. White on our server with security misconfiguration? The This is one of those gray areas between development and operations where vulnerabilities can sneak in. Developers have their set of web config files, of other config files, and a lot of times explicit errors are turned on to make their lives easier when they're debugging. It would be easier if they just didn't write buggy code, but be that as it may, if the remote errors being turned off slips into production, you take a risk of exposing lots and lots of information to anyone in the world because ASP.NET can be very, very friendly about error messages, and it can tell you what it's looking for. It can give you source code of where the error happened. It can give you a stack trace. It can give you the full location of the source file, as well as what particular version of ASP.NET is running. As an attacker, if I see this screen, I see lots of vectors for an attack on this. I know that maybe this particular version of ASP.NET is vulnerable to that denial of service attack that they patched about a year ago. I can see that they're talking to a database. I can see the column names that they're looking for. I can see some source code and look and see maybe there's something here like, oh, if they have that special ID, they're an administrator. That made my life a lot easier. Secondly, server level configurations and security patches. There's lots of releases out there, and there's a lot of tools, and a lot of administrators are much more on top of this, but it's always, always important to keep production systems patched as quickly as possible, because there can be lower level vulnerabilities, there can be attacks, and even with ASP.NET there are patches out there because there have been denial of service attacks, and in the future there very well could be other attacks against it because it is code that's written by people. But the major defense here is always keep everything correctly updated and have a really good management process, especially for those configuration files that cross those boundaries. And if the developer gets something into a production version, it could expose a lot of data that you don't want exposed. Our next vulnerability, I ran out of clue characters and I haven't dipped into my kids' set of Clue Master Detective with other characters. So we're going to be without people for the next few, but we'll muddle through. Insecure cryptography. Don't ever let your developers write their own crypto routines. Not only that, but strongly, strongly recommend getting any sort of code that uses crypto routines reviewed by a professional, by someone who knows what they're doing with cryptography, because it may be a very secure crypto implementation, like, oh yeah, we're using AES 384 bits, it's all great. Well, yeah, but your encryption key is all ones. You know, you can have the best crypto in the world, you screw up the key, then you're hosed. This also goes for passwords. We're still storing a lot of passwords in all of these individual silos. These top 5 companies have had password breaches in the last year and a half. Not only have they had password breaches, but the passwords were crackable. Either through LinkedIn, they were hashed. That's fine, unless I happen to have a video card on my system, in which case I can crack your MD5 or SHA-1 passwords in minutes to hours if you're not doing any sort of stretching and salting in defense of them. If you're just doing a single MD5 or SHA-1 hash, if I got a video card, I got it. Hell, I go out to Google and I query your hash and I can get it back. Yahoo was actually clear text passwords, even more fun. Tesco is on there. They haven't yet been breached, but there is an Australian security blogger named Troy Hunt. Strongly recommend reading his blog. It's very entertaining. It's very interesting. It's a great read for developers. He has written a book that he's made available for free in a PDF where he goes through all of the OWASP top 10 vulnerabilities, the ones that we're going through here, walks through exactly how they work, and walks through how to defend yourself in .NET. It's a great resource for developers. It's in the references at the end of the slides, and these slides will be up on